we will start the session formally. So now I like to welcome Mr. A. Vasisthar from final year mechanical engineering to propose the welcome address for the today's session.
Very good afternoon to one and all gathered here. In this auspicious occasion, I would like to welcome you all for today's webinar titled Units and Manufacturing Technology. A winner is a dreamer who never gives up. With this quote, it's a pleasure to welcome one such inspiring person, Dr. P. Suresh Kumar, Associate Professor, Department of Mechanical Engineering, Ramco Institute of Technology, who is the presenter for today's webinar. The essence of great leadership is influence and not authority. With this note, I would like to welcome the respected principal of our institution, Dr. L. Ganeshan, to this webinar. We celebrate your leadership and you keep on influencing us. We welcome you, sir. It's our honor to welcome the Vice Principal, Dr. S. Rajakarnagaran, the Head of Mechanical Engineering, Ramco Institute of Technology, who puts his soul and heart in uplifting others, attains dignity. We welcome you, sir. I would like to welcome the faculty coordinator of IE, Mr. J. Jebint, Assistant Professor, Department of Mechanical Engineering, Ramco Institute of Technology, who giving us the opportunity to conduct this type of events, and also welcoming the faculty members and student coordinators. Last but not least, I sincerely welcome all my student friends. Once again, I welcome everyone for today's workshop. Thank you for giving the opportunity.
Thank you, Mr. A. Vasisthar. Then now I will like to welcome Mr. J. Jebin, Assistant Professor, Department of Mechanical Engineering, Ramco Institute of Technology, to say a few words about our today's chief guest.
Thank you. Yes, thank you, Jabin sir. Good afternoon to all present here, the students, members, and other maybe faculty members, other part of the institution, and our institution is also. It is an interesting session actually. Why actually first we want to give the importance of this units in scientific and calculation. Why we came up this idea for giving a webinar regarding this unit system. Actually, we were seeing many many occasions the students were did mistakes in while changing the unit or converting the unit from one unit to other unit. We are actually at present we are not going to talk about the complete definition of the each and every parts, each and every kind of variables. We are just to what is the conversions, only the conversions of units. So say meter to mm conversion, centimeter to meter conversion, or meter to centimeter conversion. Like that we want to present to in this seminar because of the students were did more mistakes on writing the examinations or in exam unit system in examinations, and because of that they have got a reduction of mark. And also unit is very important, as we all know that, because if you change the unit from mm to meter means you can imagine it, how it will be look like. Suppose we have parts like small parts, if you say small part, if measurement, in that case, if you write it in meter, what could be the imagination? If you see that, suppose a dam, if you take the dam, there you cannot measure it in there you can measure it in meter. Suppose you take a pen, you can measure it in centimeter, you can't do it in a meter like that. So there is a difference maybe there. So that we want to insist that where we have to use it in meters and and centimeters, and how the conversion to be used in the unit system. That is our idea of we started to give the lectures. Actually, we have limited time, only 1 hour only. But the units are there are so much of kind. It is like a ocean. So we thought we have to give the some small introduction or small spark for the students to understand the unit system and scientific calculation in the engineering subjects, especially in mechanical engineering subjects. In mechanical engineering system, we have divided the manufacturing, design, and the thermal system. Another 2 days, we have you might you will see that manufacturing, design and thermal unit system. But in manufacturing, all the unit system and all interlinked. We cannot differentiate manufacturing unit system and design unit system and thermal unit system, because everywhere we have to use it. Suppose you have to use the speed meter per second, that there manufacturing also you are using it for per minutes for feed, per minutes for feed. That minutes you can change it to second, that you will get a velocity in the design part, meter per second. So it is not that same unit. In manufacturing technology unit and design unit and thermal unit system, all the units are in engineering unit system that used in the mechanical engineering. That is what we want to convey to you, all the students. Now I wanted to share my screen. So Jabin sir, can you able to see my screen, sir? Okay. Now, what is it in the unit system as per this units in dimension, engineering and scientific calculation? Whenever we do any calculation, you have to imagine that what that calculation usage. Whether the calculation should be, imagine some like a smaller object or bigger object or medium object or like that, you have to imagine it. Sometimes the people are blindly, they can measure it and writing the answer is 10,000 kg or 50,000 kg, like small beam calculation itself, beam calculation or any volume calculation, 10,000 kg, 15,000 kg, but it is a small object. Maybe like if you see the picture, like this kind of object, they can finally, they are solving some simple formula they are using, and finally they will conclude it at 10,000 kg or 15 kg. They cannot imagine it. Whatever the formula they have used, they can immediately take it to that value and substitute that value. So they won't decide that this answer is applicable or feasible or not. That is the big mistake. The students are, not only students, people are committed mistake in the calculations. So that is what, because they use the formula correctly, but they may have done a mistake in that conversion of unit system. Maybe they can use for instead of using meter per second, they can use it for meter per minute, like that. Simple example I am talking about it. If you say that, so that will reduce. Suppose 60 per 60, you have to divide it. Per 60 you have to divide it, but they cannot divide it per 60. They will get some answer. They can easily copy it. They need not worry about that, because they may be satisfied that they have substituted all the values in correct way. So they got answer whatever that formula. They blindly accepted that formula, but formula is there. But what in the formula, each and every variable, what is the unit can be used? That you have to understand it. That is what very important phenomenon to hear. So I want just give you some history about the unit system. In this class, fully history of unit system, how the SA unit systems are formed, and how they are taken, what is the initial stage period, the metric system, the birth of metric system, and SA unit formations, the committee formations. Now they recently 2019 they redefined the unit system, that we will see. I'm going to talk only the fundamental unit system, fundamental units. So I cannot go for the unit conversion. Maybe at later, if the time permits, I will give some 2-3 derived unit system, 2-3 unit derived unit system. Tomorrow, another gentleman will take next tomorrow and day after tomorrow, another 2 gentlemen will take the remaining part of the derived unit systems, are where the design and the thermal and manufacturing uses unit system. So this is what the content I am going to present today this webinar. So I want this timeline is a birth of metric systems, birth of metric system, and Jabin sir, when you see that slide, that timeline slide, yes. So actually in 1789, the birth of metric system, the French unit systems, weight and measure. You can take Arthur Young, that the person where started that unit system, birth of metric system in 1789. So during the time, French system contained 250,000 different units measures of weights and measures. 250,000 units were they used under the period of 1789. That is a different, maybe different orientation of unit, or different value of unit, different way of unit they are measuring at the period of 1789. And author, they wrote in the books called Precious Dimension, the history of units from 1791 to 2018, the author by Malcolm Cooper and Jim Grazier. So that person were written that book. 1718 they were used to, France used to 250,000 different units in measures, weights and measures. So later they need a strong standardization need during, because 250,000 means a little bit confusion of each and every unit system, the standardization need. So during the time, the standardization of weight and length were showing sign of wear and tear, sign of wear and tear. From that they measured weight and length. Wear and tear mean, you know that wear and tear means that material losses and tearing of the materials. That system they used to mark the weight and length of the objects. Then later they have changed, and the period of some 1791, assembly defined 2 new unit of mass and length, not in terms of arbitrary physical standards, the quantity, but the reference to quantity which were regarded as taken from the nature. They taken from the nature. The meter was defined 1/10 million of meridian arc from north pole to equator. So that is here. The author, as I told, the author Young 250,000 unit system, where this is some stones were used, maybe little bit to make confusion, so that Rosetta stone for the author when they used for unit definitions. Here different units, here position L. What is that L? L dash means is the differential of dou L by dou T. This differentiation with respect to L, and the force can be measured ML, and these 2 dash is the d squared L by dt square. D squared L by dt square. Like that, this is the stone, Rosetta stones used for interconnecting between the basic unit systems, force and work and velocity and position and inertia, moment, power, momentum and velocity. This is the stone were used. You can Google it and search it and understand it. It is a stone were used for author and M to understand the unit on the each basic variables. And this is the meridian. As I told that 1/10 that is a meter, the distance. So the 1/10 million of meridian arc from the north pole to equator. This from to here 1/10 million meridian arc were measured in the olden days. So that days they were used to these meridian calculations. And another this is for meter, and they were used that kilogram. Instead of kilogram they used the grave stipulated with the mass. How the mass is measured: 1 cubic decimeter of distilled water, that is pure water, at the melting point of ice. 1 cubic decimeter, that means you can see here 1 cubic decimeter used, this decimeter, 1 cubic decimeter used, 10 centimeter is equal to 1 decimeter, thus you know. So 1 cubic decimeter ice cube, I mean distilled water at the melting point of ice, that is called as a kilogram. So that this meter can measure this equator to north, and kg can measured by this way. And this was the olden days, that is 1791. During the period they used meter and kilogram measurement of, by using this measurement. And this also a little bit confusion that measurement north pole to equator measurement, but it is open that from this point only they started to measure it. So this idea is developing the unit systems. And later some Royal Society of Metric System was obtained in the 30th March 1791. So that they used the definition of a unit system. Like that, unit systems are started from the olden days. That started from the meter and kilogram only. That is the fundamental unit system. They were worked on different portion of different part of the years. Each and different years they used a different concept to define the unit system. Now, what I'm going to say here, what is the fundamental unit system here? That is defined by the SI unit system. How the SI in standard international system of unit, they derived the unit system. Okay, fundamental system of unit system. International standard of international system of unity, SI unit system. So they have some 7 basic unit system, fundamental units, 7 basic fundamental unit system. So how they obtained and how the international system of unit arrived. So first I want to tell you some stories regarding this actually. So in international system of unit, here there are can say standard of internal system of unit system, 7 basic unit system, that is meter, kilogram and ampere, Kelvin, mole and cantilever. These 7 unit system were used, and these are all called as a fundamental unit system. Based on the fundamental unit system, will have additional unit system are called the derived unit system. So derived unit system is like based on the fundamental, you can use the fundamental unit system to derive the other unit system called derived unit system. So that is the main kind of things to hear in the actually in the fundamental unit system we have in the some SI unit system. 1 minute. Actually that is a controlling body. The SI unit system was maintained by the controlling body. General Conference on Weights and Measures So in practice, that is CGPM committee were decided to find it, decided the unit measurement system. So CGM recommendation only consulting committee, which is actually body conducting technical deliberating concerning new scientific and technological development related to the definition of unit and SA unit system. So International Committee for Weight and Measures (CPM), that committees are defined that based on the committee, these are the three committees were combined together and formed the SA unit system. That SA unit systems here KG and these are the seven SI unit system, basic unit system, base fundamental unit system, and these fundamental unit system from the fundamental unit system, and we are deriving the different unit system called you can say derived unit systems. Okay. This is the fundamental units. So mass, length and time, current and time, temperature, amount of substance and luminous intensity. The units are kilogram, meter, time, second, ampere, Kelvin, amount of substance is mole, luminous intensity, candela. So these seven unit system is a fundamental unit system. Based on the fundamental unit system, we have to take in the derived unit system. So these seven fundamental unit system used, then the mass, you know that mass, amount of matter in the object. So based on this, they calculated the mass of systems, and you can say during the if you say mass of the system, immediately you can come to that weight. So weight in the sense with respect to the gravitational force, we say that is weight. So sometimes the mass both component is same, mass is the same, but depends on the gravitational action, it may be different. Sometimes if you take the same mass 50 kg to in earth, same 50 kg in the in the moon, that weight is different. So you know the difference of mass and weight with respect to gravitational force. So gravitational may vary in a different bodies, like sun is gravitational surface gravity is 274.1 meter per second square. Mercury is 3.703 meter per second square. So Earth is 9.81. This we know, you know, and Venus is 8.872. Moon is 1.625. Mars is 3.728. Jupiter is 25.93. Saturn is 11.19. Uranus is 9.09. Neptune is 11.28. This is the surface gravity. It depends on the gravity. It varies the weight of the content, but mass remains the same. Mass, wherever you take, mass is that. Weight is with respect to the variation, like directions. Direction, mass, everywhere you take the mass, the same amount, 10 kg only. But weight can vary with respect to the gravity of. Okay. So this is called mass and fundamental unit system. But here, these three are repeatedly used in the mechanicals. Mass, length and times, these three are repeatedly used in the mechanical engineering field. So I am going to take here some of the derived unit system and based on the fundamental unit system. So this also you can use it in temperature in the thermal concept. This you can get it in after day after tomorrow. Sorry, next day after tomorrow. Then I can teach these three by using these three how the derived unit systems are used, and also I will touch upon the MLT system in the fundamental unit system. MLT system means that I have to tell you in this because it is very important to say that MLT system when you are talking about the unit systems. So mass, length, time, can take mass, length, time, and you know the definitions. I will give you the seven quantity definition. Mass is the amount of substance and material in object. Length, distance between the 2 points. Time is the duration between two incident of event, or one event happen now, another event, what is the time period duration? So you can say 10 minutes, 5 minutes, like that. And current is the flow of electron from the high potential to low potential region. Temperature is a measure of how hot or cold object or substance in based on the comparative scale. And amount of substance is a measure of amount of elementary entities such as atoms, moles, and other particles. Luminous intensity is a measure of amount of light that point source radiates in a given direction. So these are the seven unit fundamental unit system. So these but in mechanical we repeatedly these three are used in design field. This may be used in thermal field, but I am going to talk about this three in the by using these three we'll go for the derived unit systems. Derived, I will give you some four or five derived unit system and also MLT system in the based on this actually. These are some telescopic approach they used in the olden days, Boda telescopic approach. There are two telescopic here, and they can this in common axis. They can use this telescopic and to draw the 2 points to mark an angle. So this angle is to by using this angle they can convert into the linear scale to measure the meter. That is called repeating circle surveying instruments. Based on this angle, you can use the sine rule to find out the length in the sense meter measurement. So this olden days they were used this triangulation using Boda repeating circle and to find it. So that's Then want to give here a minute. Actually, we thought to give symbol more history. I don't want to give the more history on this because sometimes the history may get bored. So we'll go to the topic. Actually, fundamental. You can say fundamental real case usage. The real case uses that I am going to talk about in this class. Real case usage. Real case usage means suppose you conversion of meter to mm to centimeter. How you can convert it 10 in 10 power minus 2. So meter to whatever. Okay. So fundamental units here, as you know, that mass and length and time. These three are fundamental units used in the here in the mechanical, and also we are using it for design calculations, the mass and length and time. So this can be a symbol of used in the symbol of mass for m, then length is L, time is T. Okay, time is T. So for this calculation, so same we used the dimension. Same for this dimension is also M, L, T. So it is called the MLT systems. MLT system. And so I'm going to do that. So these are the basic units into mass, length and time, and symbol used this MLT. Now I am going to take each and every quantity. So whatever I have, remember that quantity value is used in this in our subject. I will take that quantity and what is the symbol used for it. Maybe in different books they used different symbols, but need not to symbol, we left out the symbol because some books were used to this symbol, some books were used to this symbol. We not care about the symbols, but want to care about the MLT system, unit and MLT systems. Okay, so suppose if I take for the case geometric unit based on the geometric, they say shape and size. Can say some area is the quantity and volume is the quantity. So geometric unit, geometric quantity. So this geometric will be area and volume. So in the area, for area, can use that area. What is the, you can simply the basic unit system here, mass unit is mass is kilogram. That is the SI unit. Kilogram. Length is meter is the unit. Time second. Okay. Second. Okay. So for area calculation, we used length into breadth. So that is the area. Sometimes in circular you can use pi by 4 d squared, and different shape you can use different area. But ultimately it will come to this two linear measurement, two linear dimensions. Say length is a linear dimension, two linear dimension multiplied with you will get it. Okay. For geometric, for here area meter into meter. So is equal to meter square, between length and breadth. Okay, area for this meter square. For this MLT system, you can use for kg meter m, and for meter L, and for second L T. So here for MLT system, for this, for meter L and this meter L, can use L square. That is the MLT system. MLT system sometimes used FLT system also, force and the LT system, force FLT system. Okay, that is a weight based. Okay, so here mass based, weight based FLT system used, but MLT system is the basic. So area is equal to mass, meter into meter is equal to meter square. So per meter length, and this meter is a length L square. For volume calculations, you know meter square. So meter into meter. Sometimes you used, I'm just considering like a cubic structure. So for cubic structure, I am calculating this volume. You can take any kind of volume structure. So volume should be a multiplication of 3 linear dimensions. You will get a meter cube here. So meter cube. Same way for meter L into L. So it is called L cube. This is a MLT system for this. This is for geometric conditions. For the case of kinematic quantities, why I am taking this basic quantity, this can be, these variables can be used in any mechanics field, engineering mechanics or mechanics field, because the mechanics is the basic subject. You can basic subject for our mechanical engineering. So use this mechanic concept to all kind of subjects. So that is why I taken as the mechanic subject, what the unit system used in this. So kinetic quantities like velocity. Kinematic quantity means you can't give the external forces to move. So it can move an inherent force, inertia force itself. That is a kinematic quantity. So you need not to give any external force to boost the movement of the object. Just I have standing here myself for my own inertia axis, inertia based on inertia, body inertia can run. So that is a kinematic. Suppose kinetic, if you take kinetic, you will give the external force to it. Okay. So velocity, velocity is the unit is meter per second. With respect to the second, how the distance and what is the difference of speed and velocity means. Velocity can go in the specific direction. Speed cannot go the specific direction, but the units are both are same, meter per second. Per second, how much distance it can move. Eவ்வளவு distance move per second in but the specific direction, if you take it, that's called velocity. If you not taken specific direction, that is called a speed. Okay. So that is because it has some vector quantities. This is vector in the sense direction quantities. Okay. So this is a vector quantity. It has a magnitude and direction velocity. So meter per second. So meter per second is you know that for meter L used per second is second time t. Okay. For second time t used in dimensional t system for second. So for meter length. So I can write L t power minus 1. This is for the MLT system. Why I am insisting this MLT system? If you write it in the form of MLT system, you will get easy to understand it, because sometime I will give the importance of MLT system later, next 1 or 2 minutes, after 2 minutes. And then angular velocity. Angular velocity. Your angular velocity is then radian per second. Radian per second. Only you have to consider that. This is the linear movement. Meter is the linear movement. But whereas here circular movement, angular or circular movement, you can take radius instead of meter, linear length meter. So you can take is a radius per second. So for radius you can not have the unit, but a second you can have a unit 1 by per t time. Second for second MLT. MLT quantity t. So is equal to t power minus 1. Not unit, radian not having some dimension here. And second for second the dimension is t. So t power minus 1. That is for angular velocity. Acceleration. That is rate of change of velocity. Whereas here velocity you can say rate of change of distance. Rate of change of distance. How much distance it can move with respect to the time. So here rate of change of velocity, how the velocity movement in the with respect to time. So velocity here, for velocity you can take meter per second, you can use here, but here second. So you will get meter per second square here, meter per second square. So per meter L used and second t square used. So L t power minus 2. This is for the acceleration. And this for the acceleration, that is for kinematic quantity. Next unit here, angular acceleration. Angular acceleration. Angular acceleration. Angular acceleration. For angular acceleration, same like angular velocity. So our angular velocity, the rotation per second, or radian per second, whereas here same radian, but with respect to second and then radius, angular velocity divided by second. How the changes in angular velocity divided by time. So divided by time. So for angular velocity, you take radian per second, that is the unit, again per second per time. So we get a radian per second square. Radian per second square. For this MLT is radian, as you know, as I said in the previous one, for radian no dimension, so per second square t dimension used. So we get equal to t power minus 2. T power minus 2 for angular acceleration. So for discharge, there is another kinematic quantity, discharge. Discharge means the rate of flow. How much flow can occur with respect to the time. So flow can occur means volume, how much volume rate of flow or flow rate. Then for this unit is volume flow rate. Here and use volume per time. Volume per time. So for volume, take meter cube per time second. Okay. So meter cube for volume and time per second. Second for time. So for this case, for meter cube, can use L cube here per second. T is equal to L cube t power minus 1. This is for discharge. This is for discharge. And then acceleration due to gravity. Acceleration due to gravity, that is G value. G value. Based on the G value only, you can change it mass into weight. Sometimes we used to say that what is the weight of the body. So you can say some 50 kg or 40 kg. That is a misnomer to use. Actually, you can use it 50 kg means 500, approximately 500 Newton. Somebody, if you ask the weight of your body in this, if somebody asked your body's weight, how much weight means you are 500 Newton. And like that you say. So G value, that unit of G is, it is also acceleration. It is also one of the acceleration. So acceleration unit is meter per second square. So rate of change of velocity, meter per second square. It means here can say v dv divided by dt. You want to give this simple, actually, maybe you may, sometimes you may well versed in this unit system, but our intention of this webinar is to give the small unit conversions, how the conversion takes place. Here velocity is meter per second, again this second used here, so you can get meter per second square, acceleration due to gravity. So you can, for this case, L divided by t square is equal to L t power minus 2. Same like acceleration. Same like we used here, acceleration. Okay. This is also same acceleration due to gravity, g value. Then dynamic viscosity. Dynamic viscosity. So this dynamic viscosity, it is like a dynamic property. So the non-used, it is another main comes kinematic viscosity. The dynamic viscosity is the dynamic quantity, not kinematic quantity. So the kinematic viscosity used in this. Okay, kinematic viscosity. So for this unit is meter square per second. Okay, meter square. Sometimes we used to say that stroke. Usually used this stroke. Stroke means 1 centimeter square per second. Stroke. The kinematic viscosity is sometimes you put the name of that stroke. Stroke kinematic viscosity. Whereas dynamic viscosity we used to poise. Okay, poise. Then they stroke 1 centimeter square per second. If you want to convert to meter square per second, 1 centimeter square per second here, 1 centimeter per square per second is equal to, suppose I want to convert to meter square per second, here, see, listen, centimeter square is, to convert to centimeter to meter is, 1 centimeter is equal to 10 power minus 2 meter, okay, is equal to 0.1, okay, whatever, 0.1 or 10 power minus 2 meter like that. So suppose this centimeter square means into 1 in 10 power minus 2, the whole square. The square will come to here. Because centimeter into centimeter. So you can take 10 power minus 2 for 1 centimeter to meter and another 10 power minus 2 for 1 centimeter to meter. So 1 in 10 power minus 2 whole square divided per second. Divided by seconds. So you will get 1 centimeter square per second. Okay, sorry, 1 meter square per second. Convert to meter square per second. So that means 1 centimeter square per second is equal to 1 into 10 power minus 4 meter square per second. 10 power minus 4 per second, meter square per second. So same way here, for this case, MLT system is dimension system is for a meter L square and the second T. So is equal to L square T power minus 1. This is the system kinematic viscosity. You know the viscosity, the resistance or movement of fluid. That is viscosity. Kinematic viscosity means for kinematic viscosity can take mu by rho. This mu is called as a dynamic viscosity. This mu is called a dynamic viscosity divided by density. So if you divide it by density, you will get a kinematic viscosity. For this case, meter square per second used. Okay. Then how the conversion it can be takes place. The definition based on the definition, how the conversion will take place, we'll see later. So what is dynamic viscosity? That next section I will explain this dynamic viscosity unit. If you substitute dynamic viscosity divided by this value, cancel all this value, we will get this value. Okay, that we will do it one or two conversion value. Now at present, you have to understand the units are some basic quantities or physical quantities. Okay. Then another these are kinematic quantities. Then dynamic quantities. Dynamic quantities, the preliminary main dynamic quantity is force. Okay, force. The rate of change of momentum. The rate of change of momentum is called force, or you can say force equal to mass into acceleration. So mass into acceleration. This you can remember this. Force is mass times into accelerations, or you can say it is the rate of change of momentum. The force is called rate of change of momentum. So I can write m into dv divided by dt. That means the rate of change of velocity of acceleration. So this is mass is constant. You can take it to mass constant to differential here. So d by dt of mv. Mv is the momentum. Okay, momentum respect to rate of change of momentum. You can say force rate of change of momentum. Now the force, the unit is, unit is Newton. Newton. After the invention of the Newton, so you can say you can say it's a Newton. But what is the unit of this? Here, preliminary this unit is, or basic unit is kg meter per second square. How it comes then? As you know that force equal to mass into acceleration. For mass kg, acceleration is meter per second square, as we derived last. So meter per second square. Same you need to bring here, kg meter per second square. Kg meter per second square. That is for force. Okay, that is for force. Now this force, for this force, what is the dimension to be here? For kg, m. For kg m, for kg m, for kg m here, for meter L divided by second t square is equal to m L t power minus 2. This for mlt for force. Okay, for force. Second, next quantity is weight. This is also not a force. Weight is also not a force. So this also Newton only. Unit is Newton. So mass time gravity. Here instead of A, acceleration is the linear movement of the here. Suppose the linear movement of force equal to mass into acceleration. Linear motion of this acceleration. But for the case of weight is force into mass into gravity, the downward acceleration, downward movement. Okay, the acceleration due to gravity, g. So same unit for used that Newton used for weight. Yeah. Then that means kg meter per second square, plus kg for mass, g due to gravity is meter per second. This also acceleration meter per second. So I can write a m L t square is equal to m L t power minus 2. T power minus 2. This is for the weight. Then another quantity is like specific weight. Specific weight. Weight per volume. Weight per volume is specific weight. Weight per volume is equal to specific weight. For weight, use Newton. Now it will come the derived unit. So why it called as a derived unit? This unit can be derived from the basic unit system. The unit along the basic unit kg, meter and second. These three quantities finally it will come to the basic unit. So it is called derived unit system. This for Newton, then meter cube volume. For Newton, kg, meter per second square. Here meter square, meter cube, then meter cube, meter cancel, then you will get a here kg divided by meter square and second square, meter square and second square. For this MLT is kg m and meter square L square and second T square, and write m L minus 2 T minus 2 for specific weight per volume. And fourth is another quantity is dynamic viscosity. It is what previously we had a kinematic viscosity in the previous kinematic quantity. Here dynamic quantity, dynamic viscosity. For dynamic viscosity, unit is Newton second per meter square. How it will comes then? How it will come? This unit is dynamic viscosity is as this unit is derived from the Newton law of motion, sorry, viscosity and not motion, Newton law of viscosity. What it says, Newton law of viscosity. Newton law of viscosity says the shear stress developed at the fluid and fluid interaction, shear stress is developed is directly proportional to the rate of change of velocity or velocity gradient. Sorry, velocity gradient. Okay, velocity gradient. Okay, y velocity gradient. So our rate of shear strain or velocity gradient or rate of change of velocity. So then this proportionality removed, then you will get a mu into du by dy. Some variable can be multiplied by removing this. This variable is called dynamic viscosity. Dynamic viscosity. So because the stress to be involved, so it's called dynamic viscosity. Stress to be involved here, this is dynamic viscosity. So then for this case, this is a stress. It's a shear stress, but what is generally it is stress. For stress unit is Newton per meter square. This shear stress unit is Newton per meter square. Okay, we'll talk about later shear stress. Newton per meter square and is equal to, this will come to here, then I can write here mu is equal to tau divided by du by dy. So is equal to tau is Newton per meter square, that is shear stress, divided by this is meter per second, then this divided by meter distance. So I can cancel this value. Second will go this side, upper side, Newton second per meter square. That is the unit for dynamic viscosity. This is the unit for dynamic viscosity here. Now the dynamic viscosity Newton second per meter square. This Newton again I have to break it into the basic unit system. So for Newton kg meter per second square, as we know that for Newton here into second divided by meter square. So second cancel. So kg meter kg cancel. Then finally kg get to here meter 1 meter here and 1 second here, meter second. Okay, kg meter second. Then for this MLT system is dimension system is for kg m, then second L, sorry, meter L, second T. So we'll get m L power minus 1 T power minus 1, ml power minus 1 T power minus 1. This is for dynamic viscosity. So how I have taken the dynamic viscosity? This is a basic content. If you forgot to write the unit in the any kind of unit, if you forgot to write any unit for any quantity, you have to remember the basic definition of that quantity. Say like force. Force, you know that mass into acceleration here. So from that you have to take it the unit. And this is dynamic viscosity. This is the definition of dynamic viscosity. I have taken the dynamic viscosity definition. From that I have derived the unit of this dynamic viscosity, which is what units are derived. Then another quantity in this pressure intensity, the pressure intensity used in the mostly fluid problems. Pressure intensity, for pressure intensity, same. What is the unit used for stress? That is a force by area. What is stress and pressure intensity? Both are unit Newton per meter square. So what is the difference to be here? These two. So augmental stress is called the pressure. Augmental stress means it is a perpendicular surface. Whatever the stress to be acted on this, if it is acting the perpendicular to the surface to be here, whatever the stress to be acted on the perpendicular to the surface, that is called a pressure. If you take any, pressure should be a perpendicular to the surface. Whereas in other stresses are maybe shear stress like this and this, another stress like this. Okay, but pressure should be always to the perpendicular to the surface. So that is what difference between stress and pressure. So pressure is one kind of stress, normal stress. Okay, it is a normal or principal stress. Pressure is the one of the principal stress. So it's called this one. So it is force by area. That is the definition, force by area. So force equal to Newton divided by meter square. Same way, Newton kg meter per second square divided by second meter square. Now meter cancel. So kg meter second square, kg meter per second, meter second square, kg m, then meter l, t square. So equal to m l power minus 1 t power minus 2. That's what. So it will come to the basic unit system here. So, but in exam point of view, remember this unit and how the conversion to be takes place, that you remember it. But when you understand the topic or when you understand the quantity, physical quantity, you should remember this physical dimensions. These physical dimensions give the meaning of this. Fundamental dimension give the meaning of the physical quantity. That you should always remember. Then another variable, remember a variable, modulus of elasticity, both in the same. Stress and pressure are modulus of elasticity, or modulus of shear modulus. So all are the same unit only. All are the same unit system. ml power minus 1 t minus Newton per meter square only. Newton per meter square only. And surface tension. Next for the surface tension. This is what is the definition of surface tension is unbalanced tensile force acting at the surface, two different phases. Can be like formation of bubbles at the soap bubbles at the surface. We are detergent used, soap bubbles at the surface. There the two phases are there, air and water. If you take air and water, and in between their phases, unbalanced tensile force. That means not balanced, because if your water inside the water, it will be like the water content here, all the direction, equal amount of force to be acted here. But this is a free surface of water, it is okay. But in this case, only this direction of water, we get these forces. But here, due to this unbalance, it will create like this spherical shape. To compensate this, there is a tensile force to be acting this direction. So this is called unbalanced tensile. So this is the surface tension. Surface tension. Like example, some insect stands stand on this surface of water. Insect stands on the surface of water, or pin you are put on the pin on the water bucket. It will be like அந்த emerge ஆகாம அப்படியே சர்ஃபேஸ்ல இருக்கும். So that is the condition of surface tension. So for surface tension, this is a tensile force. Tensile force at the distance only. Tensile force, the distance only, Newton per meter. Or another definition, if you some more energy, if you take in terms of energy, energy that is spent at the area, okay, at that area to form the surface tension. How much energy to spend to form the spherical shape in this area. So that is called energy divided by area, or else force divided by linear distance. Force divided by linear distance. So Newton per meter surface tension. Here for Newton, kg meter per second square. Another again basic meter cancel, kg per second square. So kg per second square. So then it will be n power minus 2. So t power minus 2. Mt power minus 2. Okay, m t power minus 2. That is for surface tension. So then stress, as I told, work energy. So capacity of that work to be done, this power. So that you can be studied in the day after tomorrow classes. This is what some of the definition. One thing you should remember, that if you whatever you are doing the unit conversion, one thing, very important thing, is dimensional homogeneity to be maintained. Dimensional homogeneity in the sense, if you have the dimension in the left hand side is equal to same dimension to be maintained in the right hand side. That is the system in the dimensional homogeneity. Both sides same unit, you should have to maintain it. Suppose you take a velocity is equal to root of 2gh. This is for one quantity. It is used in the some devices, beta-tube devices or velocity measurement devices. So for velocity meter per second, as we know that, what is the unit here? I can take this g value, meter per second square, and this h is meter. So we'll get a root of meter square per second square is equal to meter per second. Same units to be maintained. That you have to remember this. Whenever you use the units, dimensional homogeneity to be maintained in the whole system. So any system of unit, you have to maintain the dimensional homogeneity. So this is what I have given some more information related to this unit system. So some unit derived it. So how the derivation to be taken, I will tell you one of things. We will take a kinematic viscosity. I'll give one example here, kinematic viscosity. Kinematic viscosity is equal to, as in dynamic viscosity, the definition is dynamic viscosity. We forgot the unit, remember the definition of the quantity. From there you can derive the unit, density. So dynamic viscosity unit is Newton second per meter square. Density unit is kg per meter cube. Now here the kg is there, but here Newton. But we want to convert to this in Newton to kg, so that it can cancel. It can cancel and we will get a unit. For Newton, kg meter per second square and second. This you should remember, that Newton for Newton, kg per meters per second square. Mass into acceleration. Same is second per meter square. Then divided by kg per meter cube. Okay. Then kg cancel. So Meter, meter cancel, second, second cancel. So meter cube, 1 meter to be here, cancel, this meter and this meter cancel. So we'll get a meter squared, this will go up. The second already 1 second is there, so meter squared per second. This you remember this. Whenever you take, you forgot to the unit of the any quantity, you remember the definition of the quantity. You can take it from the other source of unit, other source of units. Say for example, suppose what is the unit for the specific gravity? If you sometimes use the specific gravity unit is, some people were written some specific gravity unit is some unit, but there is no unit for the specific gravity. How do you ensure it? But the definition of specific gravity, you know that weight density of unknown liquid divided by weight density of known liquid or known substance. Weight density of known substance and unknown substance, and weight density. Weight density means you can take directly density value. So density of unknown substance, because weight density means kg g cancel, g cancel. So only you get rho value. That is the density. Then known substance. So both are density. Density cancel, you will get a no unit here. There is no unit for this. Sometimes when you are solving the problem, unknowingly you can write the specific gravity value some kg per meter cube. That is not correct. Okay. So you remember that each and every variable, imagine that, or imagine, and what is the physical meaning of that quantity, physical quantity. So according to that, you have to write your unit system. So unit is very, 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 very important. If you change the unit, definitely you will get a 0 mark. Okay. So maybe sometimes you ask, sir, I solved all the problems, but finally only unit changed. If you say like this, so suppose you are going for an industry, doing some applications, instead of you are designing some like a dam, bridges, like that. If you change that, instead of meter, if you change that some different unit, அதே வந்து நம்ம செஞ்சோம்னா என்ன ஆகும்? The structure will be collapsed. So you are doing small mistake, that unit mistake, that will lead to the collapse of the system. So that is the power of unit system. Unit there's so much power to influence on it. So you have to take care of the unit system whenever you solve the problem, because I have faced many problems during my PG studies. So if you are solving that page by page problem, so finally the unit is wrong, they will put a 0 mark. That is the final condition. You can't ask that step mark and all. So no reason, there is no meaning at all. So that's what I'm again and again insist to you. I have some more unit, some more quantities are there. That will take, and the next two gentlemen will give the they will give the introduction, or they will explain it. So that's all about my lecture, but I have just given small introduction on that unit system. I thought to give more history oriented one, but I think they may get sometimes bored of it. That is why I taken some more unit, some unit systems are there. So at the end of the third day, if we 3 people we are taking for the unit system, we missed any unit system. Third day we 3 will come to this webinar, and we will clarify the other units, whichever left in out of these 3 days. So we will do it on the day of last remaining unit system, unit definition and unit derivation or unit changes. So basic unit, remember that. Basic unit, you have to remember that based on the unit, you have to derive all the unit system. I have taken this very basic unit only. So definition and all, I explained it, each and every variable definitions. And I think, I hope you understand these lectures. Thank you. I think this is a basic unit I have given, but I think we have our intention to give those basic elements for the exam purpose only. If you want the brief history about each and every term, what they are using in the olden days, we will go one day definitely. Otherwise, we will, Jabin sir, we will have a separate question and answer session after end of the day, because once they understand the unit, all the unit, they will ask the questions actually. Any question, any quantity they missed it, we have three of we missed it, they will ask that quantity, we will derive that unit at the end of third day.
Sir. Okay. So thank you, Suresh Kumar sir, for your wonderful presentation of the units in the basic units and also the units in manufacturing technology. So now the time to close this. So now I welcome Mr. S. P. from Mechanical Engineering. Mechanical Engineering propose the vote of thanks for the today's webinar.
Good evening to all. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first start giving the glory to the Almighty God for making today's occasion a resounding success. First and foremost, I thank our special guest, Dr. P. Suresh Kumar, Associate Professor, Department of Mechanical Engineering, Ramco Institute of Technology, who, despite his busy schedule, has found time to grace this occasion. Thank him for his kindness, interest, and continued support. Thank you, sir. I thank our principal and vice principal for their unstained support for this function. A heartfelt thanks to the head of the various departments and faculties for their valuable contribution and guidance and encouragement in all our efforts. I owe special gratitude to the who have worked hard to ensure that this occasion becomes a memorable success. I thank all the distinguished dignitaries present here accepting our invitation. Last but not the least, thank you, my friends, for your cooperation in making this function a resounding success. Once again, I thank you all for your occasion. Thank you all. Thank you.